Hi, my name is XelaPil. I'm from the CQU Gladstone campus, and I'm here to talk about the different types of structural loads. Let's begin. Today we're going to talk about the definition of structural loads, the two different types of accepted classifications of loads depending on the nature of action, which are construction and analysis, and the different ways that load can be applied on a structure for load application modes. Structural loads are defined as forces applied by elements causing stress on the structure or its components. These stresses are carefully considered, as too much stress will cause cracks or breakage on the elements over time. There are different types of loads associated with civil constructed buildings. They can be broadly classified as primary loads and secondary loads. There are three different types of loads that are considered as primary loads. There's dead load, live load, and wind load. Dead load is relative to the permanent fixtures like the partition walls and the weight of the different materials used for construction. These loads are transferred to the structure throughout its lifetime. These are the loads that are considered as the minimum load to be withstand if the structure is not intended for occupancy. Live load or imposed load are movable or moving loads without any acceleration or impact. These loads are assumed to be produced by the intended use or the occupancy of the building. Wind load is primary horizontal loads caused by the movement of air relative to the earth. Wind load is required to be considered in designs, especially for high-rise buildings and skyscrapers. Secondary loads. These are loads that may occur due to the environment in which a structure will be constructed at. Not all are always applicable for designing, unlike primary loads, which is always a must to be considered. Secondary loads include snow load, where the impact of snow falling on the roof and the force applied by the resting snow on the roof is considered. Thermal load, where the temperature of the environment affects the expansion and contraction of some elements. Shrinkage load, where over a period of time, certain building materials, such as concrete, will shrink, causing cracks on the slabs, while bricks swell, causing uneven levels. Dynamic load, which include impacts caused by vehicle collision or aerodynamic loads caused by something as small as air movement around a slender aerial, will result in vibration that is transferred through the building and the structure. Seismic load are considered in earthquake-prone areas such as places in the Southeast Asia, although most buildings are now designed to withstand minor earthquakes because they are often very unpredictable. Sediment load. The uneven settling of material the building is constructed on will cause stress in the structure, resulting in a differential settlement. The stresses may be so severe that it may result in significant structural damage. The effects of secondary loads can be minimized by applying controls to the building design, such as anti-vibration pads for dynamic loading, control joints for settlement loading, or even design modifications for shrinkage and thermal loading, and many more. For structural analyzing purposes, forces can also be classified as vertical loads, where forces are applied along the y-axis, horizontal loads, where forces are applied along the x-axis, or longitudinal loads, where traction and braking forces are considered in special cases of bridge designs. These loads can be applied as concentrated load or a point load, where a single force is acting over a relatively small area. For example, a column load on the floor of a building, or a stationary vehicle wheel load on a bridge. Another application will be a distributed load or uniformly distributed load, where a load is acting over a surface area, which is then calculated in units of force per unit length. An example will be the weight of the floor or roofing material on a house. Another application is a varying load or a non-uniformly distributed load. This type of distribution's magnitude varies along the loading length with a constant decreasing or ascending rate. Now, for an application exercise. If I was an engineer to construct a bridge, I would consider the dead load on the bridge with the materials I'm using, the live load on the bridge for the occupants that's going to use the bridge, the wind load on the bridge, the cyclone rating on the area, the settlement loads on the material that it's resting on, the thermal loading for the expansion and contraction of the elements, seismic loading for withstanding earthquakes, and the shrinkage of concrete for when I use concrete on my supports. Now for a quick recap. We have discussed the constructional classifications of loads as primary loads, where the loads are always considered when designing building structures to ensure quality. As secondary loads, where these types of loads are dependent on the environmental characteristics, which in turn may affect the structure's integrity. For analysis, loads can be classed into vertical, horizontal, and longitudinal loads. This simplified segregation is to enable ease of calculations for structural design. And lastly, we discuss the different ways that the forces are applied. Again, the importance of these identified classes are to enable engineers to accurately account for the loads applied on and control the stresses on the structure. Thank you for watching. For any inquiries, please do not hesitate to contact me. My email is displayed on the screen. Thank you again and have a great day.